Hello guys, welcome back to Chemistry 24/7. In this series, we have been exploring solutions for previous year competitive exam papers. If you are new to this channel, don't forget to subscribe and hit the bell icon for the notifications. Let's dive into the today's problem. Today, we will tackle a question from the University of Hyderabad PhD entrance exam 2019. According to this question, this 1,3 cyclic ketone initially react with sodium hydroxide and followed by methyl iodide. In the second step, which react with ethanol in the presence of acid, which produce compound X. This product X further react with LDA and followed by methyl iodide, which produce compound Y or product Y. So here you see there are four options. Let's figure out which one is the correct option for this question. Start with our first reaction condition. So the reaction of sodium hydroxide with this 1,3 cyclic ketone. So here you see this position has two acidic proton. This acidic proton present in between two carbonyl group. So when you use sodium hydroxide, it readily abstract one of its proton. So resulting that generate this corresponding enolate ion. So after the formation of enolate ion, which readily react with methyl iodide. So here you see this electron shifted here, this electron attack this carbon, then followed by kick of I- to produce this methylated 1,3 cyclic ketone as an intermediate. In general, ketones can be present at the small amount of corresponding enolic form. This keto-enol tautomerism can be triggered by using acid catalysis. So same thing happened here also. When you use ethanol in the presence of acid, that triggers into the keto-enol tautomerism. So here you see this keto form now converted into the corresponding enolic form. Both are present at the equilibrium. So now you see in the presence of acid medium in ethanol, which produce that corresponding protonated ethanol. So here you see this one is a protonated ethanol. Now you see this enolic form in oxygen atom has two lone pair of electron. So one of its lone pair of electron readily attack this carbon. So resulting that this electron shifted towards to the oxygen atom, then followed by kick of water as a byproduct. And the meantime, so here you see oxygen already donated its electron to this center. Therefore, oxygen will get positive charge, then followed by loss of H plus to produce this corresponding intermediate. So in particular, this reaction named as etherification reaction. So our next reaction condition, which involves the LDA. Before moving the LDA, I would like to give small recall of our LDA. LDA means that lithium di-isopropyl amide. So which is a non-nucleophilic sterically hindered strong base that readily abstract the proton from acidic position. We have already discussed LDA before, but if you missed that video, don't worry, you can find the link in the description box below. LDA is particularly useful for generating enolate ions by deprotonate the less hindered side of a corresponding substrate. Let's moving on our substrate. So closely look, our substrate has two active sides. One is here, another one is here. So depends on base, we can generate either kinetic enolate or thermodynamically stable enolate. When you use LDA, which readily generate kinetic enolate, while when you use potassium tertiary butoxide kind of bases that readily generate corresponding thermodynamically stable enolate. So in our case, they provided as LDA as a base. Therefore, when you use LDA, which readily abstract the proton from this side, which produce this corresponding kinetic enolate. So after the formation of kinetic enolate, which readily react with methyl iodide in the subsequent step, here you see this electron shifted here, this electron attack this carbon, then followed by kick of I- to produce this corresponding alkylated ketone as a product. So this is the product Y. Finally, we arrived our answer Y. So apart from that, this particular ketone product is most important for the synthesis of gamma substituted ketones. So from this, if we do a couple of steps, we could reach the corresponding gamma substituted ketone. For example, when you treat this ketone by lithium aluminum hydride and followed by acid workup, which readily produce this corresponding gamma substituted ketone, in the whole set of reaction sequence is known as Stork-Danheiser Alkylation. Based on our analysis, along with the concept of alkylation and keto-enol tautomerism and followed by the LDA based construct such as kinetic enolate as well as thermodynamically stable enolate, we can easily derive our correct answer for this question is option A. That's it for today's problem. If you found this video is helpful, please give it a thumbs up and don't forget to share it with your friends and make sure to subscribe and hit the bell icon so you never miss any update from ChemOrgChem. And finally, thanks for watching and see you in next video. Bye bye.